The purpose of the session is just to clarify what is the difference between a class and an interface and an abstract class, and what problems do they solve and how can we use them. So what I want you to do, well, let's talk about it first, and then the exercise is going to be to make some tests pass. In order to make the test pass, you have to add in some logic to some classes and some interfaces and see how they work together. So most of the time spent will be seeing how these things interact with each other and how we do this, and then we'll do a Q&A at the end. Loosely, the main thing to think about an interface is an abstraction. So what do I mean by abstraction? It is sort of a way to represent some behavior or some logic that you want to use in different places. And so rather than keep everything within a class and having to repeat those same methods in many classes, we make the abstraction say that all these methods are going to be used in lots of places. And so we're going to create an interface. And that interface defines those methods. So let's look at an example. This is an example of an interface, a very simple one. Let me make it a bit bigger. Declared an interface and has two methods. And this idea is saying I want to be able to use these two methods or define these two methods in different classes. And so the important thing about an interface is saying I'm going to define the methods. They don't have any method bodies, if you notice. It's just simply the method names and a type. And if I want to implement this interface in a class, I have to use the implement keyword. So if I were to implement this interface, let's go to my child class. Don't get confused by parent and child in terms of any relationship. They're just two separate classes. I was just using the domain of human beings and decided those were the two things. So if I want to be able to implement it, the first thing I need to do is import it, because there is in a separate package at the moment. So I guess I'll do something like this. And I would implement it using the implement keyword. You can implement multiple interfaces. In this case, I'm implementing movement. And you can comma separate lots of different interfaces. If you implement an interface, it is essentially, think of it in terms of like a contract to say that if you implement an interface, you have to make sure that you implement all of its methods. So you have some guarantee that a class that implements an interface always has those methods. You can't just implement part of it. You have to implement all of the methods. So once you implement an interface, then you have to then define them. If my movement says it's these two methods, then I've got to make sure I define them. In this case, I need to have them with method bodies. And it's good practice to add the annotation override when you are implementing an interface, just to make sure that the method names are the same. So we'll throw errors if it doesn't see that this is defined in the parent class or the interface. Because you might think you're trying to override it, but you might change the case one of the characters, and you end up defining an extra method. So override will help catch that. It will always look to an interface or a class and make sure that it's already defined. So in this case, we could define it. There's actually a test here that will tell me what I need to do. Here are the tests to assert that it has these methods. So notice what I will want you to do is have a look at in the tests, which are the methods or which are the interfaces that you need to implement, and then do so accordingly. So in the child's test, we have a hello method, a walk, and a jump. The walk and the jump come from the movement interface. So I have to make sure I implement the movement interface. And then my child test says, let's go to the playground. That's the return value for the walk method. And then I'm going to add the other one, which is this. So in this way, my child class, class child, has implemented the interface. It has the two methods, and I've declared it. And it's also quite readable, so you know when if other people come to your method that the override means that it's been implemented or extended from somewhere else. So it's useful, and not just to catch errors, but also to give indication to other people that when they read your code, these are methods that have been overridden. So there's the other part to this is if you have a look at the child test, is that there is also a method say hello that we need to implement somehow. So the say hello method, I want you to define a hello method from the abstract class. Now, an abstract class is the same as a class, but with the restriction that you can't create an instance from it. So you always have to extend it. So if you have a look at the human test, the only way that we can test an abstract class is by extending it, because we can't quote an instance of it. So we have to create essentially a mock for the test. We create a class within the test that extends it, and then we can make sure that the class that extends that abstract class has the right behavior. So we'll do the same thing in the child. I want to be able to extend the abstract class. And once I extend it, I have access to all of its methods. So very, very similar to inheritance. It is inheritance. It's very similar. What I meant to say is very similar to how we've done inheritance in Node.js, where you just extend a class. Once you extend it, you have access to its methods. So what I'm looking for in this exercise is for you to define the say hello method here in your abstract class, and then extend it. So you should do something like extends human. Once it extends it, then this child test should pass by default because it inherits that behavior if you've defined the say hello method in your human class. So there are two parts to this. All right. One part is making sure that your classes, child and parent, both implement the right interfaces and then extend human. And in order for this abstract class to work, you have to define the method. So the first step I recommend, start with the human test, get this to pass. Make sure that abstract class implements a say hello method. Once your human class, your human abstract class has this method, then you can go to your child class, make sure it extends it, and then implements the right interface. And you understand which is the right interface by looking at the test. So the difference between the parent test, the parent has no movement, it just sleeps. Whereas the child does lots of movement and sleeps. Cool. Sound good?
I just had a question. It's interfaces and abstracts, just basically templates.
Depends on what you mean by a template. So an interface is essentially a contract saying every class that implements this has to have these methods. So it's some guarantee of I don't know, convention that when something implements an interface, you know all those methods exist. And you see them. Inheritance, when you extend, especially an abstract class, you can define a lot of behavior there, and it sort of hides it away. Both are ways of sort of like creating abstractions. An interface is useful for readability and provides some measure of like, as I said, guarantee that all of these methods are implemented. As with anything, a blueprint or as you said, a template is the right kind of idea. Yeah. Now the difference between them is generally try to sort of stay away from abstract classes. Interfaces are usually the way to go. There are some specific use cases where abstract classes are useful. In the same way that normal inheritance. Inheritance isn't that good of an idea because you get into a bunch of problems. But interfaces are better. And both are using the same point. Both are trying to help solve the same problem, which is essentially encapsulation, trying to encapsulate behavior in one place. So interface is where you would go to change behavior, or at least the methods, the method names. Okay, more questions?
Yeah, you said to change the method names is where you go for the interface. So if I change my method name in my interface, does that automatically change all the classes that rely on that interface?
You would have to, absolutely, yes.
Or would I have to do that manually?
It depends on your IDE. Your IDE, I'm sure, might be able to configure and do that automatically. Otherwise, it's manual. But the idea is the interface is the source of truth for the methods that need to be implemented. Now you can overload them as long as you have the same method name, but it still has to be implemented. Cool. Okay, we're going to pair up and we're going to start with making sure that the human test passes and then go to the child and the parent, thinking about the difference between abstract class, and interface. This is commented out because if you were to run it, it would show you that it can't compile it because it's an abstract class. It'll give you an error saying you can't instantiate an abstract class. So this is there if you wanted to try that out. Okay, I'm going to stop sharing my screen. I'm going to form some breakout rooms. 6, 7. This is going to be some person. Let's do 6 then. Cool. I forgot to